We now discuss the solution of a problem from the section Trigonometry. The given question is on the number of solutions of a given trigonometrical equation in an given interval. This question has appeared in Joint Entrance Examination Main held on 25th June 2022 in the first shift. The given question is the number of values of x in the interval, in the open interval pi by 4, 7 pi by 4, for which this equation 14 cosecant square x minus 2 sin square x is equal to 21 minus 4 cos square x holds. We have to find the number of solutions of this trigonometrical equation in this open interval pi by 4 to 7 pi by 4. We now discuss the solution of the problem in detail. That's your given question. We have this given trigonometrical equation. Let's call this as the equation 1. Now, writing for cosecant square x 1 by sin square x and for cos square x 1 minus sin square x, we get this equation. Now, simplifying, we get 14 by sin square x minus 6 sin square x minus 17 is equal to 0. Now, take the LCM, then you will get 14 minus 6 sin power 4x minus 17 sin square x is equal to 0. Now, reorganize the terms, we get 6 sin power 4x plus 17 sin square x minus 14 is equal to 0. Put t is equal to sin square x. Then you will get 6t square plus 17t minus 14 is equal to 0, where t is sin square x. 6 14s are 6 into minus 14, that is minus 84, and that can be written as 21 times minus 4. Then 21 plus minus 4 is 17. So that is the factorization that we make it. Then the factors are 3t minus 2 into 2t plus 7 is equal to 0. Then you will get t is equal to 2 by 3 and t is equal to minus 7 by 2, where t is sin square x, is a square of it. So sin square x cannot be minus 7 by 2 because no square of any real number is negative. So sin square x, we take it 2 by 3, which is less than 1, and we reject sin square x is equal to minus 7 by 2 because the square of any real number is never negative. Therefore, sin square x is equal to 2 by 3 will imply sin x is equal to plus or minus under the square root of 2 by 3. We continue in the next slide. So that's what we have done so far. The number of values of x in this open interval pi by 4 to 7 pi by 4, for which this given trigonometrical equation holds, is given by the number of values of x in the open interval pi by 4 to 7 pi by 4, for which sin of x is equal to plus or minus under the square root of 2 by 3. So what are the values of x in this open interval for which these two hold? So how many of them? That we will do. Note that sin x is equal to under the square root of 2 by 3, which is less than 1. This implies x belongs to 0 to pi. So sin value, positive value, can be in first quadrant and in second quadrant. That is, x belongs to 0 to pi. Sin x is equal to minus under the square root of 2 by 3. Then x belongs to the open interval pi to 2 pi, that is third and fourth quadrants. So first let us take case 1. Alpha, let alpha belongs to the 0 to pi by 2, open interval 0 to pi by 2. Then sin alpha, and let alpha belongs to the open interval 0 to pi by 2, and sin alpha is equal to under the square root of 2 by 3. What is that alpha? So now what we see is 1 by 2 less than 2 by 3 less than 1. Yes. And taking the square root throughout, square root of 1 by 2 less than square root of 2 by 3 less than 1. And this is sin pi by 4 less than sin alpha less than sin pi by 2. And sin is an increasing function in this interval pi by 4 to pi by 2. So this will imply alpha belongs to open interval pi by 4 to pi by 2, which is contained in pi by 4, open interval pi by 4 to 7 pi by 4. Therefore alpha is a solution. So we got one solution in the first quadrant. Agreed. Take the second. Let beta is equal to pi minus alpha. Pi minus alpha is definitely less than pi, so beta less than pi. Therefore beta belongs to pi by 4 to 7 pi by 4. Yes. And sine of beta is equal to sine of beta is pi minus alpha. That's called sine alpha. Sine alpha is root 2 by 3. So this is our the second solution in the second quadrant. Now move to the third. Let gamma is equal to pi plus alpha. And now gamma is equal to pi plus alpha is less than 3 pi by 2. Why? Because alpha less than pi by 2. When alpha less than pi by 2, pi plus alpha is less than 3 pi by 2. Therefore gamma belongs to less than 3 pi by 2 means well within this interval. So gamma belongs to pi by 4 to 7 pi by 4. And let us see sine of gamma is how much? Sine of gamma is equal to sine of pi plus alpha is equal to minus sine alpha is equal to minus under the square root of 2 by 3. This is the third solution. Right. Fourth, let delta is equal to 2 pi minus alpha, and pi by 4 less than alpha. Yes, alpha is greater than pi by 4. Minus alpha, send this, minus alpha less than minus pi by 4. Now add 2 pi on both the sides, you will get 2 pi minus alpha less than 2 pi minus pi by 4. But 2 pi minus alpha, which we have denoted by delta, therefore delta less than 2 pi minus pi by 4 is 7 pi by 4. So delta less than 7 by 4. This will imply delta belongs to the open interval pi by 4 to 7 pi by 4. And what is sine delta? Sine delta is equal to sine of 2 pi minus alpha is minus sine alpha, that is equal to minus under the square root of 2 by 3. So this is our fourth solution. So thus the number of values of x in this open interval pi by 4 to 7 pi by 4, for which sine of x is equal to plus or minus root under the square root of 2 by 3 whole is 4. They are alpha, beta, gamma and delta as described above. Thus the answer for this question, is 4. What was our question? The number of values of x in this open interval pi by 4 to 7 pi by 4 for which the given equation 1 holds is 4. So the answer is 4 for this question, and that is the detailed discussion of the solution of the problem on the number of solutions of a given quadratic equation in a given open interval. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.